Find the derivative of y equals f of x plus g of x from first principles. So first we name f of x plus g of x as s of x, and that allows us to write down the derivative of that quantity. Since y equals s of x, then dy by dx equals the limit as h tends to 0 of s of x plus h minus s of x all over h. And we recall that the derivative of f of x, which is f dashed of x, is given by the limit as h tends to 0 of f of x plus h minus f of x over h. And similarly for the derivative of g of x, g dashed of x. Now given that s of x equals f of x plus g of x, then s of x plus h equals f of x plus h plus g of x plus h. And so we have that dy by dx equals the limit as h tends to 0 of s of x plus h minus s of x over h. And we make the following substitutions, after which we obtain this quantity and we expand the second bracket to get the limit as h tends to 0 of f of x plus h plus g of x plus h minus f of x minus g of x all over h. And now we note that these quantities appear in the definition of f dashed of x, and that these quantities appear in the definition of g dashed of x. And so we rearrange the numerator to group those quantities accordingly, and we split the single fraction into two accordingly. We now have the limit of a sum, which we split into the sum of limits, and we note that this quantity is f dashed of x, and that this quantity is g dashed of x. And so finally we obtain that dy by dx equals f dashed of x plus g dashed of x. And so if y equals f of x plus g of x, then dy by dx equals f dashed of x plus g dashed of x. Informally, this result says that to differentiate the sum of two terms, we differentiate each term separately and then we add the derivatives. So, for example, if f of x equals x squared, then f dashed of x equals 2x, and if g of x equals x cubed, then g dashed of x equals 3x squared. And so if y equals f of x plus g of x, which equals x squared plus x cubed, then dy by dx equals d by dx of x squared plus x cubed, where x squared is f of x and x cubed is g of x. And due to the result that we have just proven, we can split the single derivative into the sum of two derivatives, as so. And we note that d by dx of x squared is f dashed of x, which is 2x, and that d by dx of x cubed is g dashed of x, which is 3x squared. And so finally we have that dy by dx equals 2x plus 3x squared.